Good morning, everyone. I hope you guys are all doing well. Today, for our e-learning, we are going to be covering the second half of section 7 in chapter 1. So right here today, we are going to be covering the distance formula. This is how you're going to do those last few problems on the worksheet that we gave you before. So again, the distance formula, section 7, here we go. So right here it is. Here's the distance formula. As Mr. Renneker and I told you guys when we were doing the midpoint formula yesterday, you don't have to memorize this. So this will be given to you, but you do need to know how to plug it in. This is how we find the distance between 2 points. So if we have 2 points, x1, y1, x2, y2, remember x always comes first in both points, and y always comes second in both points. Alright, so we have x coordinates of each point and the y coordinate of each point. x1 just means x of my first, y of my first. x2 is x of the second point and y of the second point. So to find the distance, or to find out how far apart they are, like here's point A and point B, to find the distance, that shortest straight line distance, to find out how long that is, we can use this formula right here. It is the square root of x2 minus x1 squared. So first we subtract the x coordinates from each other and then square it, plus y2 minus y1 squared. So we subtract the y coordinates from each other and then square that. After we've subtracted and squared, we add those up, and then we finally take the square root at the very end. And a lot of these are going to come out to be decimals, and we'll just round them off to either 1 or 2 decimal points. Will let you know where it should be for individual problems. So we'll get to working through some problems with that here in just a second. But real quick, something that's going to be important for those of you who are going to be taking the grade 10 math I-STEP here in a few weeks or months, I forget exactly when it is, but the distance formula is actually based on the Pythagorean theorem, which if you know any theorem of mathematics, it's this Pythagorean theorem, the a squared plus b squared equals c squared. Because if you look at this picture, we have a right triangle right here, and this x2 minus x1, that'll tell us how long this side is, that's A. And when we do y2 minus y1, that'll tell us how long this side is, that's the B. And remember, each one of those subtraction problems was squared. So here's A squared plus B squared equals C squared. And then you take the square root to get C by itself. On the I-STEP, they'll ask you to find distances between points, and they'll provide you with the Pythagorean theorem. So that's how they're expecting you to find those. This example right here, again, you can find this on Canvas. This is just a problem worked out for you to see how it goes. So we have 2 ordered pairs, -7, 5, and 4, -3. So that's x of my first, so -7 is x1. That's y of my first point, so 5 is y1. And then here we have v, this is x of my second point, and y of my second point. So x2 is 4 and y2 is -3. I highly recommend, and Mr. Renneker and I have talked, and he recommends it as well, labeling those as the x1, y1, x2, y2, so that way you can get everything put in the right spots. That's one of the biggest problems people make, is not putting numbers in the right spot because you don't take the time to label them like that. But once you have these labeled, x2 minus x1 squared plus y2 minus y1 squared. This gives you 11 squared is 121. This gives you -8 squared. When you square a negative number, it becomes positive. Be careful of that. If you're not careful, some of your calculators, if you don't put the parentheses, when you do -8 squared, it's going to say -64. Be careful. When you square a number, it always has to be positive, because -8 times -8, negative times negative always gives you positive. 121 plus 64 is 185, and then we just do the square root of 185 is about 13.6, just rounding it off. All right. Now to try some out on our own. Here we go, two ordered pairs. Here's x of my first, y of my first, x of my second, and y of my second. When we plug it into our distance formula that says distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, we have the distance is equal to the square root of 6 minus negative 6 squared plus y2 is negative 7 minus y1 is negative 2 squared. 6 minus negative 6, minus a negative is like plus positive, so 6 plus 6 is 12 squared, plus negative 7 minus negative 2 is like plus positive 2. Negative 7 plus 2 is negative 5 squared. Now again, like I said, when squaring that negative, you have to be careful. When we do 12 squared, we get 144. When we do negative 5 squared, we get positive 25. You need to make sure that you get a positive number for these. In my calculator, if I had just typed negative 5 squared without those parentheses, it gives me negative 25. I do not want that. Be very careful of that happening. So now I do 144 plus 25, and I get 169, and the square root of 169 is 13. So my distance is 13. Remember, if you get a negative number, when you square it, it has to be positive. The other mistakes, make sure you add before you square. Add in here before you square. And then once they've both been squared, then add them up and take the square root at the very end. All right, let's try another one. Always label x of my first point, y of my first point, x of my second point, y of my second point. When we plug them into our distance formula, it is x2, so 8, minus x1, 6, plus y2 is negative 3, minus y1 is 1 squared. 8 minus 6 is 2 squared. Negative 3 minus 1 is negative 4 squared. 2 times 2 is 4. Negative 4 times negative 4 is a positive 16. 4 plus 16 is 20. So our distance is equal to 20, or the square root of 20, sorry. Distance is equal to the square root of 20. So I do the square root of 20, and that gives me right around 4.5 is where that will round off. And there's our distance. Now another question that pops up is, how did I know that this one is supposed to be my first point and that one's supposed to be second? What if I wanted this to be x2 and y2 and this to be x1 and y1? Would we get the same answer? And the answer is, yeah, you'll get the exact same answer once you work everything out. So it doesn't matter which one you pick to be point 1 or point 2, just pick a point to start with, x of first, y of first, x of second, y of second. Remember, x always comes first, y always comes second. Now here we're just going to do a quick little review of the stuff that we've done in this section. 2 midpoints and then a distance, and then we'll be done. So the midpoint formula that we worked on Monday was that our midpoint has the ordered pair of x1 plus x2 over 2 gives us the x coordinate, and y1 plus y2 all over 2 gives us the y coordinate. So here they give us both endpoints, so we just plug them in. x1 plus x2 over 2, y1 plus y2 over 2, 2 plus negative 1 is 1 over 2, 4 plus 7 is 11 over 2. There it is as a fraction. As decimals, 1 divided by 2 is 0.5. 11 divided by 2 is 5.5. So there is our answer to number 1. Number 2 is also talking about midpoints. As soon as you see that word midpoint, you know midpoint formula, here we come. But this one, they give us the midpoint and one endpoint, and we have to find the coordinates of the other endpoint. So our other endpoint, C, has the ordered pair x, y. This one was a little more challenging. We said we're still using this midpoint formula here, but it's going to look just a little bit different. We have to do our endpoint, so here's an endpoint and here's an endpoint. The x coordinates get added, so x plus 3 divided by 2, the x coordinates of the endpoints added divided by 2, and that gives us the x coordinate of our midpoint. In this case, that's 5. Now we can multiply by 2 and get x plus 3 equals 10, subtract 3, and find that x is 7. So it's still using the midpoint, but it looks a little different. To find the y coordinate of our midpoint, we again are going to do the y coordinates of our endpoints. Here's an endpoint and here's an endpoint. So y plus 4, divide that by 2, and set it equal to the y coordinate of our midpoint, in this case, a -2. Now we multiply by 2, y plus 4 equals -4. Subtract 4 to get y by itself, and we have y equals -8. So I have an x coordinate, I have a y coordinate, but I need an ordered pair. X always goes first, y always goes second, so there is our midpoint. Alright, the very last one is a distance formula problem, just like what we were doing. Here is my x1, y1, x2, y2, and we just plug them in. x2 minus x1 squared plus y2 minus y1 squared, take the square root. -6 minus -9 is like plus +9, so we have 3 squared. 0 minus 8 is -8 squared. 3 times 3 is 9. -8 times -8 is going to be positive. 8 times 8 is 64. We have the square root. 9 plus 64 is 73. And to finish it out in my calculator, the square root of 73 is right around 8.5. So there you go. A little review of midpoint from yesterday, and the distance formula is the new stuff for today. Alright, read the email to find out what else you need to complete, and try to stay warm. Bye guys.